Good morning, everyone. Welcome back. So in this video, I am going to show you how to describe the transformation, okay, from the rational parent function. So the first transformation you're going to learn today is going to be the horizontal translation. So basically, the parent function has been moved horizontally, either to the left or to the right. Okay, so that's what we call horizontal, the horizon. Okay, so how would you recognize horizontal translation? Okay, given the function. So let's say you're given a function g of x equal to 1 over x. So you see the parent function 1 over x, and next to the x, you see a number being added or subtracted from the x. For my example here, I'm going to use minus h. Okay. Or in another case, it could also be where you see by the x. So any number you see being added or subtracted from the x represent the horizontal translation. And in this case here, so you have a minus h here. The next one is going to be a plus h. So now when you see that when you have a number being subtracted or added from the x, we know that you have horizontal translation. Okay. So now we have to now identify if the parent function has moved to the left or to the right. So what I would like you to remember is for horizontal translation, you're always going to remember to use the opposite. The direction is going to be the opposite of what you see, okay? Okay, so what do I mean here? So you see a minus h. You will see, okay, so the parent function is moving to the left since it's a minus. Again, you're going to think, you have to use the opposite of what you think. So if you think is because it's negative, you move to the left, it's the opposite. So the parent function has been moved to the right. So the parent function has been moved to the right, and here is going to be h unit. Okay, the next case scenario here, when you have a plus, okay, so the parent function has been moved to the left, h unit. Okay, so let me give you some example for you to practice. Okay, so the first example you're going to work on is going to be number 1. You're given the function g of x equal to 1 over x minus 3. Okay, so let's describe the transformation. So you see here, there's a number. You look on the denominator, there's a number by the x, a minus 3. So what kind of transformation do we have here? Okay, because it's a minus 3, don't think, okay, it's going to be horizontal translation for sure. Okay, because it's affecting the x. Anything affecting the x is located on the x-axis. So it's either to the left or to the right. So horizontal translation means you're going to either move to the left or to the right. Because of the minus here, 3, so you're going to think the opposite. So you're not going, the parent function has been moved not to the left but to the right. Okay. And how many units? You say 3 units. Okay, so next you're going to graph, okay, the function g of x. But before, in order to graph, you have to use the parent function. Okay, so you have to use the graph of the parent function. Okay, I have a piece of graph paper here. So I build the y-axis and the x-axis. So now I'm going to use 2 square to represent 1 unit. Okay, so that, and then I'm going to for both the x and the y-axis. So first you have to graph the parent function. Okay, so let me use the black ink to graph the parent function, which is 1 over x, f of x equal 1 over x. So I'm going to use the order pair -1, comma -1 right here. Okay, then -2, comma -0.5, which is right here. And then 1, 2, 3, skip -3, and then -4 should be right here. -4.0.25. Okay. And then if I want to use a point for negative 0.5, it's going to be -2. So remember, the function is going to apportion the asymptote by never crossing it over. Okay. So again, then the next point is going to be 1, 1, 0.5, 2, and then I have 2, 0.5, and then for the 4 is going to be 0.25, which is about right here. Okay, so that's the parent function f of x equal 1 over x. So now I need to grab the function g of x, 1 over x minus 3. We know that you have a horizontal translation, right 3 in it. So what is going to happen? Okay, you're going to move to the right 3 units. Okay, so how do we do it? So let me start from left to right. So I use a point here. Okay, this point right here, which is -4, negative 0.25, I'm going to move it 3 units to the right. But because I'm using 2 squared to represent 1 unit, so I'm going to move it 6 units. So let's do that. 1, 2, 3. 6 units squared. So this is a new point. Okay, this other pair, I'm going to move it out as well as 3 units. So you're going to be 1, 2, 3. Okay, the next one, I'm going to move it again 3 units. 1, 2, 3. And this one, this other pair is going to be 1, 2, 3. Okay. So now I'm done graphing the left side, the left piece. Let's do the right side. So I'm going to move it to the right 3 units. So this order pair, I'm going to move 1, 2, 3, and I place my dot right here. 1, 2, 3, and I place my dot right here. So I cannot continue further because it's going to be off the card. Okay. So, but you see, okay, so let me see if I can, let's assume I continue. Okay. I'm going to approximate it. So this is the x-axis. And then this point is going to be 1, 2, 3. I'm going to make it, it should be right here. And this point right here will be, okay, 1, 2, 3, somewhere right here. Okay, so now you're going to connect the dot. But before you connect the dot, okay, let's find, you see the parent function has been moved 3 units to the right. Okay, so which means it has moved 3 units to the right. It means that the vertical asymptote that were at x equals 0 has been shifted to the right three times. So the new 3 units to the right. So the new vertical asymptote is not going to be x equals 0 anymore. It's going to be the line x equal 3. So you see here that the vertical asymptote is a line x equal 3. Okay, so it's a vertical line that cuts the x-axis at 3. And how did I end up with the vertical asymptote? All you need to know is, so for the vertical asymptote, I have to find it algebraically. Okay, so you're going to look at the denominator. You take the denominator, which is x minus 3, we set equal to 0, and you solve for x. Here, in order to solve for x, you need to add 3 on both sides. And you end up with the equation x equal 3. So that's a vertical asymptote, VA. Okay, so VA is going to be a line that cuts the x-axis at 3. Okay, and the horizontal asymptote is going to be y equals 0. It remains y equals 0. Okay, so this is a line, the horizontal asymptote, the vertical asymptote. Now I'm just going to connect them, the dot, and make sure the function is apportioning the asymptote by never crossing crossing it over. Approaching the asymptote, but never crossing it over. Remember. And include the arrows at the end. Okay. Include the arrows at the end. Okay, that's a graph of the function g of x. Okay, so basically this is horizontal translation where you see that the parent function has been shifted to the right 3 units. Okay, so thank you for watching my video. Okay, so it was a pleasure being here. I hope you learned. Okay, so I would like to give you another one for something for you to practice on your own. Okay. Okay, so I would like you to pause the video and describe the transformation and graph the parent function. Okay. Graph the function g of x by using the parent function. And I'm going to give you the order pair I would like you to use. So the order pair for the parent function, f of x equal 1 over x, you're going to use the order pair -4, negative 0.25, -2, negative 0.5. Okay, so I listed the other pair I would like you to use for plotting the parent function. Okay, I will do another video that show you how to graph the parent function 1 over x. Then explain how I got those numbers. Okay, but you can use those numbers to graph the parent function, and from the parent function you can graph g of x. So please pause the video and do that right now. Thank you. Okay, so in this video you can see here you have a. So let me explain example number 2. So we have. Okay, horizontal translation, 2 units. The parent function has been moved 2 units to the left. So I use those order pair to plot the parent function in blue, which is f of x. Okay, next, what do we do next? Okay, so if you want, you can identify the vertical asymptote. How do we identify the vertical asymptote? You take the denominator, you set it equal to 0, and you solve for x. You get x equal -2. Okay, and you're going to have a vertical line that cut the x-axis at -2. And then the horizontal asymptote is the same because the parent function has not been shifted neither up nor down. So the y is still y equals 0. Okay, so then all you have to do, you're going to take each order pair and move 2 units to the left. Okay, and you end up with and connect the line and make sure that the hyperbola approaches on the asymptote but never crossing it over. Approach on the asymptote but never crossing it over. So thank you for watching my video. So the next video, I'm going to show you how to identify a vertical translation. So thank you for being here. Have a wonderful day and see you to the next one. Bye-bye.